So here's a rabbit brain up here on the top, and it's basically the paleomammalian brain, and it's tucked up inside all that wrinkly stuff that we call cortex. This one is a monkey brain. You can see the primates have a little bit more cortex, but not as involved as ours. And this is a dog brain, which is kind of a joke cartoon. You can't see it very well, but one of my friends does. So basically, here's the drawing. This is what we call the limbic system right here, and it's underneath cortex, but it's this really basic, more primitive part of the brain. And it's on top of the brainstem, which is the most primitive part of the brain. That's why rabbits don't do this, and dogs don't do this. Because even though they do have a more sophisticated repertoire of behaviors, they don't have behaviors like humans do. It turns out that what they're really best at is nurturing and being nurtured. We all have that within our brains. I don't know if any of you have heard this, probably some of the psychologists in the room have, but there was a famous experiment in Chicago many, many years ago. A psychologist named Harry Harlow took baby monkeys, and he took them away from their mothers, and then he had these two wire monkeys. One of them had food on it, which is what the mother's supposed to do, right? What everybody thought, this is what the mother's supposed to do, is feed the baby. The other one, they just had it nice and soft with a terry cloth. Baby monkeys would actually go over here to get the food, and then they go right back to the terry cloth, because that was their substitute for being nurtured. So touch is really important to the developing brain. And it turns out that most of these monkeys were really pretty disturbed monkeys because they had been taken away from their mothers. This experiment has been replicated with many, many other species of mammals. In fact, if you give them enough food and you put two mammals that we think are enemies together and raise them together, they become best friends. Because that urge to tend and befriend, or nurture and be nurtured, is so strong within our mammalian brain. So then we have to come to the cortex. Now the cortex does everything else. So in the reptilian brain we have this fight, flight, freeze response. In the mammalian brain we have this learning and feeling ability and the ability to tend and befriend, or nurture and be nurtured. But we don't have decision making, we don't have planning, we don't have language. That's all in our cortex. So if you think about, for example, I used to raise sheep when I lived in the States. So sheep would be very smart at learning where the food was. And in the wintertime, when there's no grass, they break out of their pen and they get into the barn and they go and they find where the food was stored. And they'd be eating away food, and then I'd come out and say, "What are you doing?" Just like you might to a dog in Kentucky Fried Chicken. And they would shut down, they go into their reptilian brain. So they were very capable of learning where the food was. But the minute they got cornered or challenged, they couldn't make a decision, they couldn't make a plan, they would just go like this. And so that's another illustration of why we need cortex, why we need all this wrinkly stuff on top. We do things like study and learn and define professions. We do things like solve problems. This is a tunnel in Grenada that is a perfect example of using the cortex. People used to have to go up and over the mountain, and now they can tunnel and they can go through it. So that's basically what we use our brains, our cortex for, a very human part of our brain. So there's the cortex there, and what I'm going to talk about mostly tonight is what we call the prefrontal cortex, which is right up here, because it turns out that that's the part of our brain that is most uniquely human. We also have speech and language and all kinds of other things. But what's really very cool about the cortex is this prefrontal cortex, which is right in the front, up here. Everybody go, frontal cortex, here, frontal lobe. Okay? Brainstem back here. Okay? Now we all know that we've been in our brainstem plenty in our lives. So we need techniques, and we need techniques to be able to show children, how do you get back up into your frontal lobe, where you plan, where you execute, where you decide, where you solve problems. Because that's really what that part of the brain is designed for. And here we have This is kind of I like this, it's kind of a simplified version of the way the brain works. So we have the reptile here, we have the mammal, we have the monkey, which has all the other cortex, and then what we humans have, very specifically, is this imaginative, creative ability that comes from the prefrontal cortex. And we know this not from taking pictures of brains with modern neuroimaging techniques. We know this from years and years and years of documentation of people who had head injuries. And you might even know somebody who's had a head injury. It's usually a frontal lobe injury because that's the part of the head that gets hurt. And those folks typically lose their ability to plan and problem solve. So that's really how the executive functions, as we call them, are initially discovered. So the prefrontal cortex is like the CEO of the brain. It's not fully developed until about age 24, which means adults have to loan our frontal lobes to children. I love giving lectures to medical students at SGU because I often ask them, how many of you are under 24? And half of them raise their hands. And so technically, they're still adolescents. Their frontal lobes are not fully online. Now, sometimes they use that as an excuse. Well, I did it because my frontal lobes aren't fully online. But it's really, if you think about your own life, some of you might be under 24, apologies to you. If you think about your own life, it's around that age of 23 to 25 that you started really thinking about your future and really making plans. Up until then, it all seemed like a walk in the park. And 24, and it's different for girls and boys. Sometimes it's, girls' frontal lobes come online at about 23. But our brains are fully myelinated in our frontal lobes at about age 24. Now, the thing about this is, though, that if we've had really stressful environments, really difficult experiences during our lives, that myelination doesn't take place because guess what? We are in our reptilian brain most of the time. So this is why it's so important for children to be able to have opportunities to feel safe and connected. We'll talk about that in just a second. So development depends really on the environment. A lot of people will say, oh no, it's the genes. Well, it's not the genes. The genes aren't even half the story. All genes do is they turn on protein-making, protein-synthesizing stuff within our bodies and our brains. And what that does is it causes new dendrites to form, and those new dendrites reach out to other neurons, and we make connections and we learn. That doesn't happen unless we feel safe and connected. So the bottom one there, if you can't see, it says that the frontal cortex, the prefrontal cortex, is hijacked by stress, meaning if you're really stressed for a prolonged period of time, as some of our children are, some of our adults are too, then you're going to be in your reptilian, more primitive part of your brain. You're not going to be planning, you're not going to be executing plans, you're not going to be solving problems. There's all kinds of things that you're not going to be doing. So the first order of the brain is to survive, right? We need to survive. Second is to connect, to nurture and be nurtured. This is why babies are born so helpless. They have really amazing capacity to reach out to their caregivers. And then we also need to solve problems and predict the future. And probably the reason, if there's a reason that we have this prefrontal cortex, is so that we can imagine what the future might be like. Apes, monkeys, other primates, they don't imagine, as far as we know. They do have some creativity, but it goes up to about 8 or 9 years old, which is what most of the primatologists have told me. But we humans can imagine all kinds of possibilities. So basically the brain is this giant learning machine, but its purpose is to keep us alive. So that's probably why it continued to grow and develop as humans have grown. So just to refresh, the survival is the job of the reptilian brain. Emotions, learning, and connections are the job of the paleo-mammalian brain. And beliefs, patterns, language, problem solving, predicting, basically everything that we know of as human intelligence is the job of the neocortex. And I'm specifically talking about the prefrontal cortex. So every system is dependent on all the other systems. I don't mean to sound like they're not connected. They're all very connected to each other. And what the job of a parent or an adult is to help a child build those connections among those different parts of